Good evening, everyone. I'm Nishtha, and I'm delighted to welcome you to the UDA Internship Program's final presentation workshop today. This workshop marks the culmination of our summer internship program, where talented interns from IIT Bombay, IIT Kharagpur, and IIT Madras have worked diligently on various pressing issues on topic related to maritime environment. Over the past few months, our interns have explored critical subjects such as climate change, sediment management, water resource management, underwater radiated noise management, and maritime security. Today, they will present their findings and solutions. And on July 9th also, because this workshop has been divided into two parts. On one is which is happening today on July 6th, and the other one which is happening on July 9th. We are honored to have with us esteemed experts with us who will guide us and evaluate the presentations that our interns are going to make. Without further ado, let me introduce our esteemed guests for today. We are privileged to have with us Ambassador Anup Kumar Mughal and Mr. Ashwin Shaw. Their vast experience and insights will be invaluable to our interns. And we also have with us Mr. Amar Kaul and Mr. Vijay Bhosle, sir, with us. Besides, we also have Praful sir with us, who's always been a guiding force to the Maritime Research Center and its team. Here's a quick overview of today's agenda. We will begin with presentations on climate change, followed by a session on sediment management. And on July 9th, 2024, we will reconvene for presentations on underwater radiated noise management and conclude with the topic maritime security. On the same day, we will have a segment where our research engineers will also make presentations about their work. Moving on now, I would like to invite MRC's founder and director, Dr. Commander Arnav Das, for today's welcome remark and what he would like to say about the summer internship program that happened at MRC. Over to you, sir.
Thank you, Nishtha. It's been an annual event for us and extremely delighted. We are only now growing in strength. And as we always discuss, it's the back-end team which is presenting their work, and we try and balance the front end and the back end always, so that every time we meet as a front end effort, we meet somebody, we need to tell them what we have done in the last time we met. So this is what my team supports me in every way, largely led by Sridhar to that account. And extremely happy to have Mudgal sir and Ashwin sir. Always they have been supporting us in every way possible. Prafulji definitely, he's always there. And we are also happy to welcome Vijay, Rajeji, and also Amar Kaul, who are joining us for the first time now. And we look forward to you giving us insights and which will help us in shaping our work. As you know, we have recently published our newsletter, and I would also request all of you to please go through it. There have been significant progress on all fronts. On technology also, we have been covering new frontiers. In a policy level also, we are getting good recognition. We are building new collaboration, new partnerships. So it's been exciting for us. And we look forward to more collaborations and more support from all of you. Also, before I drop my mic, I think I must thank the interns who have joined us this summer. It's their enthusiasm and energy which keeps us going. So thank you all, our fellows who have been working with us for a while now. So thank you so much for the diligent work, and definitely, you all come with fresh ideas, and, whatever we try to kind of conceive, it gets a new, fresh life when you all put your effort into it. Thank you so much. Nishtha, back to you.
Thank you so much, sir. Thank you so much, sir. Now, can we have Sridhar Prabhuraman, who is the Deputy Director of Maritime Research Center, to share the opening remark with all of us?
Thank you, Nishtha, and a very warm welcome to everyone. I think this has been, this is the third or fourth year, I believe, that we are running this annual webinar, wherein we invite all the guests to review the work that are done by our interns. Today, I'll just take 5 minutes to go through a couple of works that we have done over the past 3 years and take you all through it. So over the past 3 years, we have at MRC, we have developed around 48 different projects, which can be distributed across 9 different domains. And all the projects, all the work that you see is essentially efforts that are done by 100+ interns, research fellows, and engineers who all work on it together. We essentially follow an incremental model at MRC, wherein every work that we do is essentially we categorize it. The interns come in, they perform, they create a proof of concept of their particular research work. Then we look at the viability of that particular project, and then it is taken forward by the research fellows. Most of the interns, these research fellows essentially are the interns who stay back with us to complete their work, and wherein they feel that they would like to contribute to the underwater domain awareness framework, and they want to take the project forward and dive deeper into the study per se. So all of our work, we can essentially distribute that into different domains, starting like varying from AUV design and development, shipping noise and vibration studies, up to aquaculture and economic analysis, and climate change analysis, and its impact of it on the environment, specifically in the UDA aspect. So to quickly take you through a couple of works that we have done, some of the notable works that we have done. In AUV design and development, we have created a AUV design, which essentially is primarily used for extraction of polymetallic nodules. We know that it is due to the increase in depth, it has always been an area of concern, an area of effort per se. So we created a design which essentially includes both primary and secondary AUV. And we have, as you can see in the images, we have created subsystems for these. The idea therefore is that there's a primary AUV, there's a secondary AUV, and then the secondary AUV can detach and then go forward and then perform the picking of polymetallic nodules, and then get attaches back to the primary AUV. In that way, we essentially save the energy, as well as the secondary AUV is essentially autonomous with a separate mechanical arm to perform the extraction. The second one I would like to take you through is a passive sonar simulation project. This is something that we started with a couple of years ago. The core idea behind this is the effective, like creating a model which can perform effective detection and vulnerability assessment. So any submersible, whether autonomous or non-autonomous, when we submerge it within the water column, at what particular depth can we submerge it so that we can have the most effective deployment there. That is the proficiency of the sonar, the performance of the sonar per se is at maximum at that given particular region. That is something that this passive sonar simulator will essentially give us. And at what depth are we more vulnerable to the receiving signature? So if an adversary is trying to use their sonar to identify us, at what depth? So there are certain areas such as shadow zones in the water where the signals cannot reach effectively due to the way the environmental aspects are there, the temperature, salinity, and how the signal essentially propagates. So we identify those shadow zones. We identify those zones where you get the maximum performance if you deploy any autonomous or non-autonomous vehicle underwater, and that is what this particular project is all about. Then we have essentially done some work in basically assessment of environmental and water quality. In specifically, one thing that I would like to take all of you through is essentially for the Brahmaputra area. So the idea there again was to assess the vulnerability of urban area for flooding. So this basically involves the topography, land use patterns, drainage systems, and hydrological characteristics that we take into account of the watershed to identify the areas of high risk of flooding. The urban flooding modeling helps in designing and optimizing sustainable drainage systems that can effectively manage the stormwater runoff per se. We have done some work in shipping noise and vibration studies as well. I think this is one of the work that we have been well renowned for, and this is an amalgamation of this work is what we presented in IMO as well, which was taken forward, I believe, as part of MVPC 76. The idea again is essentially to identify instantaneously at any given point what are the different ships in the particular region and what is the noise that is emitted by those particular ships. So the image that you can see above showcases the black dot showcases the ships in the Indian Ocean region, and the colored map showcases the noise that is emitted at a frequency range of 100 Hertz. This essentially is done for marine spatial planning. The stakeholders are many, but to identify a few, definitely the marine mammals, because the noise that we generate is at the same frequency level as that of marine mammals. Basically identifying which areas is of high risk and which areas of low risk. And of course, there are other factors that come towards the maritime security as well. a high noise area means deployment of any kind of equipments will have more noise, and the signal to noise ratio, again, that signal will have to do a lot more denoising to identify what the signal is. Over the years, we have also used AI to enhance our effort. So 2 years ago, we put our first publication wherein we were the first one to use neural network to estimate the transmission loss that happens underwater. We have made a publication wherein we have constructed a neural network which is specifically trained for the Indian Ocean region, and that for any given point A and B in the Indian Ocean, we estimate the transmission loss per se. So the graph that you can see below, it showcases how our neural network compares to the existing PyRAM model, which is the mathematical model that is usually used. The main reason for this is that as we are moving towards an instantaneous noise calculation, we want an algorithm that can instantaneously provide transmission loss as well, because that's the core point for estimating the noise. And therefore, as you can see in the graph, a mathematical model, a usual model, will take a linear time. So as in when the sender receiver pairs, in this particular case, the ship and the receiver point, as in when the sender receiver pair increases, the amount of time taken to perform that computation increases. But in neural network being a different, using a different strategy, we were able to reduce it to a logarithmic time difference between 0 to 5 seconds, regardless of the number of observations, number of sender receiver pairs per se. We have also done a lot of work for sediment management and river studies per se, and identifying how we can perform sediment classification. Of course, there is also some work that is done by one of our PhD candidates, Jyoti Satalge. One of the research fellows will essentially take you through the data that we obtained from that and how we extracted useful information from it. But yes, the idea is therefore to identify that from the environmental parameters and from different studies, how can we identify what type of sediment is there under the freshwater systems. And the sediment, when you perform dredging, so what do we do of this particular sediment after you perform dredging? What is the use case for this? For all of this, it is important that we identify the type of sediment first, whether it is a clay silt or a silty clay kind of a thing. So that composition helps us to derive what is the use of the sediments that we will have after we perform the dredging for that particular region, and so on. So we have again done some essential work for snapping shrimp mapping. Snapping shrimp, as we all know, creates noise at close to 100 decibels, which is and also at the frequency range similar to that of what we use in our systems underwater. That basically means that they heavily interfere with the operation of our systems that we have underwater. We have done some important work in snapping shrimp mapping, identifying in which region we'll be able to identifying what are the regions in which snapping shrimps are found and what are the regions where the possibility of them being there is the most, what is the noise pollution that is generated by them, and so on and so forth per se. So this particular image that you can see showcases the same. Again, APY analysis. So understanding the area, productivity, and yield. We are one of the largest exporters of shrimps and seaweed. It is important for us to identify what are the ideal conditions under which shrimp and seaweed farming happen. Again, a lot of these things is something that our research fellows and interns will go through in depth. So I won't take too much time explaining these. But again, the idea is to how we can provide the consumers a viable product that would allow them to identify whether at that particular point, whatever nutrients they have, whatever is the pond temperature correct, are the nutrients that they have put, is that correct, and all those kind of things. So our application essentially, we are looking to develop something that allows them to analyze that, and at the end of the day, what is the probability of their production per se? What is the amount of production that they will have? We have been doing some work on climate change analysis. This is something over the next 10 years or so. This is something that we're looking at. So over the past 10 years or so, this is something that has taken into consideration. And we are looking at what is the impact in the underwater domain, how it impacts our GDP per se, and things like that. Again, I'm just giving a rough overview of it. Our research fellows will talk a bit more. And lastly, collision avoidance system. So far, we have done a work wherein we have used multiple machine learning models to effectively identify. So when a particular vessel is in a region, what is the probability of collision risk for that particular vessel with respect to other vessels as well as other land masses and other objects in the region. Last time we were at a point where we had used a mathematical model and we had created an application which gives you the probability of, for any given point in a river, at even any given point, it gives you the probability of collision of a particular vessel. But taking upon consideration the reviews that we got in the last time, wherein what happens when the AIS goes off, where AIS is not visible, we have also taken into consideration now the aspect of images that are given by NASA. So we are also doing some image processing now. That is again an interesting aspect that you'll get to see when the fellows make the presentation per se. That's pretty much all I have. Yeah, effectively pointing out that all the fellows, both this year and the year before this, have done incredible amount of work supporting MRC and supporting the larger framework of UDA. And I believe that today's presentations that you will see will be fruitful and will delve into the same. Thank you.
Thank you. Thanks, Sridhar. Thanks for your elaborate presentation on all the work that MRC has done in the past few years. Now moving on to the first segment of this of today's workshop. In this session, we will have MRC's fellows and interns present on the topic ESG, climate change and blue economy. Before we begin the presentations, I would like to provide some brief instructions to our interns to ensure that everything runs smoothly. So each of the presenter has been allotted 10 minutes for their presentation, and here's how we recommend you to manage time. First, please aim to complete your presentation within 8 to 9 minutes. This allows you to cover all your key points clearly and precisely. Also, make sure that you keep an eye on the time to ensure that you stay in the allotted time limit. After your presentation, there'll be a 1 minute allocation of the time for you to make the transition to the next presenter. And this will include, this might include quick questions, but I think for the question segment, we'll have all the question segment at the end of all of the presentations of today. We kindly ask all the presenters to respect the time limits to ensure that everyone has the opportunity to share their findings and thoughts. We believe that these guidelines will help us maintain a smooth flow throughout the presentation and give everyone a fair chance. Thank you all for your cooperation, and let's get started with the first presenter. I would now like to call Catherine J., who heads the publication and research team at the Maritime Research Center, to make the presentation. The topic on which Catherine will be making the presentation is blue economy in the Indian Ocean region. Over to you, Catherine.
Good evening. My name is Catherine. I am heading the research and publication department at MRC. I have a background in science and liberal arts. In this presentation, I'll be analyzing what are the various policy frontiers for blue economy in the Indian Ocean region. And essentially the governance framework and the required for achieving the blue economy goals and sustainable ocean management. So why blue economy? So in the early 2000s, when the climate change debate and the various other summits and global leaders drew attention to the various implications of climate change, the impact on ocean became prominent, plus how to achieve the various demands of the growing population became prominent. So that's when the concept of blue economy became relevant. And so blue economy essentially in itself includes the notion of sustainability. That's why blue economy is something that the world leaders are now focusing on, because the sustainability concept along with the economic prospects of oceans are combined into this particular term, blue economy. So what are the global issues that we are facing today? The global population is projected to reach 10 billion by 2050. We have unsustainable demands and environmental externalities, which includes unchecked use and pollution. We are faced with food and energy crisis, and of course the climate crisis, which includes ocean acidification, loss of biodiversity, habitat destruction, etc. So the plan that the world leaders, the various other international forums have come up with essentially includes the new ocean agenda, which includes the 5 pillars: the ocean wealth, health, equity, ocean knowledge, and finance. And this was actually to be achieved by 2020, but I think we've long passed that deadline. But essentially, the 2030 agenda is also pretty much the same, where we want to achieve an ocean where we use its wealth but maintain its health, use the ocean equitably, generate enough knowledge to understand the oceans without destructing its features, and plus we develop ocean finance so that the ocean is accessible to everybody. And in India, as such, the government also has a vision 2030 where we are trying to achieve blue economy, and blue economy is recognized as one of the 10 core dimensions of growth, which was enunciated in February 2019. We have a vast EEZ, which is about 2 million square kilometers. And this is something that is untapped and has a lot of potential. It has not been properly analyzed or mapped yet. And the Indian Ocean region itself produces a lot of opportunities because it has a lot of geopolitical significance. There are a couple of choke points which are essential for global trade, security, and energy security, etc. We have diverse economies. The countries around India in the Indian Ocean region don't exactly have the same kind of economic structure. We have rich marine biodiversity. We have abundant natural resources, non-living resources, living resources. We have essential climate vulnerability, which hasn't been studied properly, but with the data that we already have, we know that Indian Ocean is particularly vulnerable to a lot of impacts. And then we have a lot of cultural and social factors to be taken into account because of the various coastal communities that are dependent on these regions, and because India itself has a lot of a huge coastline. We have a lot of countries around India as well. So there are a lot of cultural and social factors with a lot of countries dependent on oceans significantly. And then this calls for regional cooperation. We have a lot of associations such as IORA, BeamStec, etc., where regional cooperation is being encouraged for the Indian Ocean region with a lot of agendas, but without essentially, so we have a lot of platforms to actually undertake a lot of implementation. And then we have a lot of security challenges due to piracy, the unplanned fishing, etc. So these are essentially what the background of Indian Ocean region, what you're looking at. So what are the major threats and challenges that we have? The environmental threats, of course, the infrastructure burdens and failures. So deploying a lot of infrastructure and failures of a lot of infrastructure that have already been deployed are something that is already present as a challenge. There's a lot of data gap and inadequate monitoring, lack of capability and capacity building. And there's a lot of stakeholder miscommunication. Even within India, we have a lot of different ministries, but the data sharing, the communication lines of action are something that we essentially don't have proper guidelines and proper SOPs to guide such networks. So blue economy essentially includes a lot of various industries. And but these industries don't act in silos. They are all interconnected. They all share the same space. They all share time. And implementing blue economy essentially from the policy perspective is incomplete without proper planning. And that's where marine spatial planning is essential, and which becomes the foundation of proper blue economic initiatives. That MSP makes blue economy transparent and predictable, and it gives it a proper legislative background, and actually makes you aware of the avenues for livelihood development, environmental sustainability, etc. So with the background that I've given you about what blue economy is and what is the status of blue economy, how people are thinking about blue economy, and why MSP is required for blue economy. Now, in all of these different initiatives, so these are the different initiatives by UN. which includes the sustainable ocean economy for 2050, the future of food from the sea, the ocean as solution to climate change. All these policy documents essentially give guidelines to countries to how to implement blue economy. But where is the underwater awareness in all of this, and where do we need the underwater awareness? So underwater awareness, the surface, subsurface, underwater data is essentially required so that we can make blue economy work together with sustainability, digital transformation, and strategic security. So this framework actually looks at all the four sectors together. And this leads to multidisciplinary knowledge generation that is looking at the same problem from different perspectives. And this ultimately leads to informed planning. And proper planning will essentially tell us where we lack in capacities and capabilities so that our investments are driven to proper avenues. So this is basically how we envision blue economy, the approach. So UDA feeds into MSP and MSP feeds into blue economy. So UDA essentially encompasses data collection, monitoring and simulations, data analysis, using the collected data and simulated information. And then MSP is integrating the UDA data, the zoning, the conflict resolution, the sustainability assessment, etc. And blue economy essentially is finally implementing sustainable economic activities, and also providing with enabling policy and governance, investing in innovation and research, investing in capacity building, and also implementing proper climate resilience ecosystem. So what is the benefit of this UDA-driven approach? So when I say underwater domain awareness, as an organization, MRC, we look at an economical and efficient model, which is time-saving and leads to informed decision-making, where with the available data, instead of looking for more deployment of resources, we are looking at a modeling and simulation model with after which we create scenarios. We try for a predictive analysis model where we predict different scenarios so that we can engage the stakeholders before proper investments are undertaken, before proper decisions are undertaken. So predictive analysis actually helps stakeholder engagement. And this leads to cost-effective planning. And once and then then taking it a step further to field validation. If there are any gaps, if there are any missteps, we can bring it back for adaptive management. So a policy which is based on UDA is flexible, which is very essential for any good policy. So I'll conclude with this case study that is based on Latvia, a European country. So Latvia has developed a ecosystem-based marine spatial plan for their blue economy. So they have created benthic habitat maps, and they've done extensive mapping, and they have tried to create a synergy between land and marine activities and identified a lot of conservation hotspots. And when after mapping and after strategizing their visions, goals, and what they want out of their economy out of the marine spatial plans, they've created 4 scenarios. And by the way, this is a very small country. It's about 17,656 kilometers square economics EEZ, and India has about 2 million square kilometers of EEZ. So this particular country has created 4 scenarios based on a multi-criteria analysis, which includes social, economic, environmental, and various other factors. And they have actually come up with 4 scenarios. The first scenario is for economic growth. So what kind of wind farm area should be allocated, aquaculture area should be allocated, how should the ship lanes be allowed. So this is the economic growth scenario. And then we have the social well-being scenario. And then we have the resilient marine ecosystem scenario. And then we have development within a common Baltic sea space. So if we compare it with our condition, it is the Indian Ocean region. So how will the development of India with respect to the Indian Ocean region be possible, or what are the various opportunities and gaps? So that's how we can actually correlate the plan that Latvia has done to what we can do. And this is something that is essentially has a lot of UDA factors, because it takes into account the simulation part, the mapping part, and also understanding what is happening between different industries. But essentially, this also doesn't take into consideration a lot of the underwater scenarios, the noise mapping, etc. But what we are proposing is so what the blue economy concept for Indian Ocean region essentially should consider is the underwater factors, which essentially includes the mapping of all the biodiversity in India. So we have a large area. So essentially we cannot completely take this particular example and install into our Indian Ocean region, because Indian Ocean region has various other factors. The biodiversity is very different. The noise mapping situation is different. The trade intensity is different. The communities, the intensive use, the population is different. So based on all of that, as I initially said, UDA, when we take in the framework, when you take into blue economy, strategic security, the environmental sustainability, the strategic security, etc., that's where we can come up with a blue economy plan where um, the um, the results are something which we can which will essentially give us the desired results, proper economic growth with the environmental sustainability. So the future outlook essentially will include the integration of UDA with national policies, and the required capacity in various aspects, the research, technology, and the deployment categories. So with this, I would like to conclude my presentation. Thank you.
Thank you, Catherine. Next, can we have Akash Prasad from IIT Bombay to make his presentation?
Very good afternoon to all the panels who have joined. My name is Akash, and currently I'm a student from IIT Bombay and pursuing my undergrad from metallurgy department. And at MRC, I'm working as an intern on the topic statistical inference of climate change impact in the Indian Ocean region. So basically, through this topic, I'm trying to study the effect of the climate change in Indian Ocean region. Specifically, what are the parameters like in the ocean which are changing due to the climate change? As we know, due to the anthropogenic emissions over the years, over the century, has led the conditions of the ocean, specifically the warming of the ocean, right? So which has caused some shift in the biological and other perspective. So I've tried to go through that study, and specifically I covered the Indian Ocean region and how the climate change has impacted the situation nearby. And finally I was able to, like, I'm working on it to relate it how it impacted the blue economy, specifically how will people will affected, their livelihood be affected, and how the GDP will be affected. As we know, India has a vast EEZ, which is the exclusive economic zone, from which we derives the resources and all. And currently, right, the blue economy is contributing around 4% to the India's GDP, which is a good amount. So, but the climate change over the years has uh, made the uh, made the situation for us. Specifically thing is there's a rise in the net ocean heat content, which I would like to highlight first. So as we can see, so this is the world map, which shows the net ocean heat content over the year from 1993 to 2022, and which has like recorded how the ocean heat content has been increased over the years. So if we look at the map carefully, we can have a judgment that if we look in the tropical region, so the net ocean heat content has been more in the tropical region compared to, on an average, compared to the other regions. Of course, this is related to the fact that the tropical region coincide with the equator and it receives the maximum insulations. But apart from that, the main driving force behind the rise in the heat content is also the climate change. So yeah, so like what if we see specifically in the tropical region in the near the Indian Ocean region, so the we can see a uniform increase in the heat content near the Indian Ocean region, right? So what this heat content rise has caused is like rising of the sea level and many other factors such as the destructions in the coral reefs, and in fact the decline in the oxygen levels, which are quite required for the underwater ecosystem for their sustainabilities. And of course the melting of ice is taking place, which might cause problem to the low lying coastal area region people, and in the form of floods and all. So moving to the next slide. So yeah, this is a good comparison compared to other oceans, how the net ocean heat content has been increased. So from the picture, it is clearly seen that the net Indian Ocean heat content has been like increased the most compared to the North Atlantic other oceans. So the this is a bit major concerning thing for the world, because in the 21st century the Indian Ocean region has gained its importance, specifically the strategical importance and trade wise also. In fact, many Western powers are trying to make their presence in the Indian Ocean region. So so it is specifically looking, and it should be given as an importance for the world economic development or the welfare. So moving to the next slide. So as I discussed about the net rise in the ocean heat content, so what exactly it has causing is when the ocean heat content like get increase in particular ocean, the sea surface temperature of that ocean will also increase as a result. And the like if we see quantitative wise, from the last century, the sea surface temperature for the Indian Ocean has rose by 1.2 degree on an approximate scale. But if we look at the figure for the Pacific Oceans and Atlantic Ocean, which is about only zero point 0.6 degree and 0.7 degree Celsius respectively, which is less compared to the Indian Ocean region. And hence, so if the sea surface temperature has rose that much, so that implies also that it affects the nutrient content which is present in the water. So the nutrient content decreases due to the higher SST, because the SST caused the stratification, which is basically the dividing the, like it inhibits the upwelling of the nutrient contents and also like forms layer based on the density, right? And uh, in fact the nutrients are quite essential for the marine productivity in any region. So in case of India, there were studies conducted and it was found that there is a decline in the nutrient content, specifically in the coastal region. And if we see that as we witness that the sea surface temperature is quite harmful for the sea, and in fact in the upcoming century it has been projected that the sea surface temperature would rise from 1.7 degree to 3.8 degrees Celsius. So yeah. Okay, so the because of the rising sea surface temperature, we have like witnessed the rise in the Indian Ocean Whirlpool region, which is the sea region where the sea surface temperature is greater than the 28 degrees Celsius. And for unfortunately for India, the Indian Ocean Whirlpool region has kind of increasing over the years, and it is going to be 100% in next few years. So the main problem caused by such warming pools is like they influence the climate dynamics and probably impact the ENSO oscillation pattern, and which modulates the atmospheric circulations. And of course, that due to the warming, the sea level rise also take place, and it might cause floods and might hamper the nearby habitat. And yeah, due to the high sea surface temperature, there is a chance of rising marine heat waves, and which we are witnessing over the oceans in the few years also. And the next thing, like which is happening due to the climate change, is the ocean acidification. So from the map, it is also clear that the acidic, like the pH for the Indian Ocean region is quite low compared to the global average, which is also concerning, because the high CO2 concentration will decrease the pH, of course, and there are certain entities or the animals which are in the underwater ecosystem which require the calcium carbonate for their development and for the survival. So having a less pH will, of course, like decrease the content of that such calcium carbonate ingredients in the ocean. And in fact, the coral bleach is heavily dependent on that calcium carbonate, which is quite declining over the year. Now, if I consider the impact on the blue economy, so some facts I would like to highlight, right? The Indian Ocean region itself caters to the around 33% of the world population, which is around the one third of the world population, being only the 20% of the Earth water. So we can see that already the Indian Ocean region is heavily pressurized in terms of extracting resources and all, and it's catering a huge amount of population. And the nation which are situated there near the oceans are basically having a low GDP per capita, so which also reflect heavily dependence of the people on the regions for on the ocean region for their livelihood also. And as I discussed, right, there's a 4% contribution for the GDP, and around 60 million fisher folk and fish farmers are dependent for their livelihood. And one more fact I would like to highlight: the 95% of the transportation business itself, it's through the waterways. Coming to the next thing, now I have categorized or made a mind map or flow chart, right? The how these are the four major kind of activities from which India derives its blue economy, which includes the fisheries, aquaculture, inland water transportation, offshore gas productions, and coastal tourism. So I have highlighted all the factors which are kind of hampering all these things. We can see, right, there's a fishing and aquaculture are getting hampered by the rise in the ocean heat content, ocean acidification, and nutrient cycle change and all. So yes, there are certain and other factors affecting the other part of that blue economy. So moving ahead, so this figure also shows the relation and a chain link, right? How a small change in particularly has a cascading effect and ultimately affects the whole food web and the security, food security in the region, and decrease in the livelihood. So yeah, so based on this, first I would also like to highlight what are the future change or what are the potential economic loss that has been predicted because of the climate change. So yeah, like from the research studies in India, it has been shown that there would be a decrease in the up to 10 to 30% in the fish catch rates uh, by around 2050 for different climate change scenarios. And yeah, over the years, the climate change fish rate captures has been decreased, and ultimately it results in the loss in the livelihood of the farmers, which are huge in number in India. And also, like the a huge economy is derived from the tourism, of which the coastal tourism plays a good role. And in fact, there's a probability or potential risk of around 150 billion over the years. And in fact, there's chances of coral bleaching in the Indian Ocean region by 2040, and which might have a loss of around 1.1 billion per $1.1 billion per year. So that would be affecting the coastal tourism in the country. And now for the like the solution based approach, what could steps would be taken? So UDA framework based approach is like a good starting point for all of us to mitigate the impact. So basically it's an holistic approach emphasizing a common framework for the dealing with the underwater ecosystems, which also like take considerations of the various stakeholders. Now it also, like, it is important to highlight the unique feature of the tropical waters, like to make any kind of a technology advancement and all. And in fact, there's a need of the continuous surveillance and the digital transformation for the easiness of the data accessibility, and subsequently having a marine spatial planning. So yeah, So during my internship work, I have also worked on the forming a model which can predict how the sea surface temperature is getting uh, uh, propagated inside the depth of the water, and how will it impact the underwater ecosystem. So from which we can later help in the MSP part, which is the marine spatial planning. So which includes the mapping of the resources, security, and the sustainability of the resources, and the quality and availability of the resources present inside the underwater region. So this is a good example of how the digital transformation will help in kind of accessing the data, and we can see this is for the radiated noise, but we can have the similar for the climate, sea surface temperature and all. So I would like to conclude, and yeah, that's all from my side. Thank you for this.
Thank you, Akash. Thanks for sharing all the findings and key highlights of your presentation with us and during the course of your internship. Right now, I'd like to call Divya Rai, who is an MRC fellow, to make her presentation. I think Divya will be making a presentation on the topic safeguarding the Indian Ocean, UDA and multilateral partnership.
Hi, namaskar everyone. Thank you, sir, for giving me the opportunity to give a presentation on safeguarding the Indian Ocean region, UD and the multilateral partnership. My name is Divya Rai, and I'm a research fellow at the MRC. So the presentation before me by all the presenters and speakers, they have actually made my task much easier. So I will not delve deeper into the importance and the impacts of the climate change on the Indian Ocean region, because it has already been covered by them. But I will specifically highlight one of the case studies that I have done while working on a project with the MRC, is how the climate risk assessment and taking up the case of Bay of Bengal region, which is extremely important to India. And then I have also correlated it with the need to have a UDA, underwater domain awareness, in various multilateral constructs, and how UDA can actually help us in mitigating the impacts of climate change in the future. So the content of my presentation is basically divided in section A, B, and C. The A is section A will deal with the importance of Indian Ocean region. B will highlight the climate risk assessment, a case of Bay of Bengal region. C is the case of UDA in multilateral constructs and the way forward. So the Indian Ocean region, as highlighted by the previous speakers, it actually constitutes about 2.7 billion people in the countries that lives across the coastline. Then Indian Ocean is also rich in resources. About 40% of the world offshore oil production take place in the Indian Ocean basin. Then the energy flow, around 36 million barrel per day, which is equivalent to around 40% of the world's total oil supply, and 64% of the oil trade that passes through the choke points, which are located in the Indian Ocean region. The fishing, which is the most important economic activity and one of the most important activity for the livelihood of the people who are living across the coast, they account for about 15% of the world total fishing, and then it has actually increased about 13-fold from 1950 to 2010 to around 11.5 million. This is very old data, but it's still relevant. It's still increasing day by day. The mineral resources, for example, the undersea bed, the seabed has actually a lot of rich mineral resources, which includes nodules of nickel, cobalt, iron, and massive sulfide deposits, and they are in very great quantity, which all the countries under the ISA are actually looking forward to utilize or maybe exploit in the future. So this is the map of all the choke points that exist in the Indian Ocean region. If you look at the choke points, there are around 8 choke points, that 5 to 6 choke points that are there in the Indian Ocean region. So Indian Ocean region is important not just for everyone, but also for India. So the ocean has become the vital part of our global ecosystem, and so in order to make the ocean resilient, it has become, especially in the face of climate change, it is very important to understand the ecosystem of the underwater domain, because the Indian Ocean region is facing both the natural as well as the anthropogenic threats. So this has very significant impact not only on the marine lives, but also on the human activities and the livelihood of those people. So the impacts of climate change is not only limited to the environment or the weather or the human beings. It also has an impact on the agriculture, which affects the socio-economic structure of that particular region. If there is less fishing, there is a scarcity of livelihood. The people will not be able to sustain their livelihood, and which will create a lot of political instability, as well as it will let people fighting for limited amount of resources. So the case study that I took of the Bay of Bengal region, where I've analyzed the climate risk, which the Bay of Bengal region is facing. So as we know that the geography of geography of any region is very different from each other. So before we adapt any mitigating strategy, we need to understand what are the specific vulnerability of that region. We cannot take a one shoe fit for all solution and apply it everywhere. So we need, in order to determine what the regional and the local authority needs in order to adapt the climate change, you need to assess the climate risk and how climate change will affect not just the people, the sectors, as well as the systems. So the case of Bay of Bengal region. So the Bay of Bengal region, it comprises of coastal states like Bangladesh, India, Myanmar, Thailand, and Sri Lanka as well. And they are extremely vulnerable to climate change and has historically faced numerous deaths because of cyclone. And these four nations are amongst the top 10 most vulnerable to the natural disasters. And some of the concern which are related to climate change in the region includes the increased frequency of and intensity of cyclones, which leads to more destruction and displacement. Remember that the climate-induced migration is one of the biggest threat that we will see in the future. So which will not only impact one particular country, but it will have an impact on the entire region. For example, the cyclone I was talking about, the cyclone Mocha, which caused heavy damage to the property and lives in Bangladesh and Myanmar. Earlier to that, cyclones like Amphan, Fani, Yas, and etc., which caused a lot of damage to the countries bordering the Bay of Bengal region. And because of the large number of cyclones which are hitting the coast of Bay of Bengal region, this region has actually caused around 80% of the world cyclone related deaths. And the other problem that the region is also facing is the rising sea level threat in coastal cities like Bangkok, which can be underwater by 2050. And the vulnerabilities are also high along the shores of major river. For example, Bangladesh, their coastal south and southeast district, which is Chittagong district, and Sylhet district, which will be with their communities will be impoverished on sandbars, which are facing the risk of seasonal floods. So the climate change has various impacts, not just towards the ocean, but it also has an impact on the flash floods, which can be increased, the rainfall variability, which will have an impact on the agriculture productivity, and the sea level rise, which will eventually lead to a lot of climate-induced migration. So the climate risk, which includes the increased frequency and the rising sea level and warm of temperature and climate induced migration. The map on your right, with the countries which are highlighted, the flags they highlight, they are the most vulnerable to the climate risk. So because these coastal areas are densely populated, so any increase in the sea level will have an impact on these particular regions. So climate induced hazard will also increase the conflict over the resources, the land, and the political representation, which are one of the long-standing problems in Bangladesh, and climate change is likely to enhance those potential issues. So the potential of climate-related migration, it will also inflame border issues, and it will spark conflict among the region. As we have already seen, the Rohingyas issue, the refugee issue has already been highlighted at multiple international forums. But imagine the increase in refugee and the migrants due to climate change will further increase the security threats between the countries. So moving on to impacts, as I've highlighted, there will be loss of land loss and everything. So the impacts, what are the specific impacts on India? So India being the largest country in the Bay of Bengal region, it encompasses wide variety of climates, geographic backgrounds and economic landscape. Our population has exceeded about 1.4 billion, making us the largest populated country. India is also the fourth most vulnerable country worldwide to climate change. So our inefficient disaster preparedness has also led to significant vulnerability to major weather threats, which was seen during the cyclone Amphan in 2015, which resulted in widespread destruction and displacement. So coastal states like the eastern coast of India, with states like Odisha, Andhra Pradesh, Tamil Nadu, as well as the northeastern states like Assam, Bihar, Manipur, West Bengal, are particularly susceptible to the climate-driven changes. Moreover, the presence of large number of internally displaced persons, IDPs, and the possibility of cross-border migration from Bangladesh will further increase the complexity of the situation. So, as per the Coastal Vulnerability Index of these states, Kolkata, if you look at it is highlighted in red. So, Kolkata is at high risk of coastal hazards such as coastal storm surges, rising sea level, erosion pose a serious threat, danger to the physical as well as the economic and social structure of the communities and the coastal communities and the population. The critical infrastructure that exists in the West Kolkata, for example, the ports, with the rise in sea level, they will be at the higher vulnerability, which will also lead to diversion of trade, and the trade will also get impacted. And once the trade impacted, the entire region or the entire country will get impacted because of the issue of inflation and subsequent issues which may follow up in the future. So vulnerability of the eastern coast, I know the picture is not very clear, but this was a study which was done by IPCC, which says that has warned about 1 meter rise in the sea level by 2100, and if 1 meter rise of sea level is going to be there, the red highlighted area of those states will be underwater. So the population living in those areas will be highly affected by it, and if they are going to displace one particular location to another, which will further enhance the problem and the complexities that India is already facing. So what are the optimum solutions? So our solution can be optimum utilization of resources. India should be leading in the front. They should act as an opportunity. They should take it as an opportunity to act as a voice of South Asia in global forums, learning from one another and cooperation under BIMSTEC. But the question that arises is, how do we achieve these solutions? So that's why we need to adopt the underwater domain awareness framework in various multilateral constructs. Because if you don't address the climate change issue at the very root cause, then you won't be able to mitigate it at the higher level. So underwater domain awareness framework exactly addresses those issues. So the multilateralism, that it's the smaller countries which are there in the region, the wider Indian Ocean region, they do not have any voices. If you look at the international forum, their voices are not mostly heard under the security threats, for example, the invasion, the South China Sea, gray zone warfare and everything. So the climate issue get somehow disappeared in the conversation. So we need a multilateral approach where the smaller countries can actually voice their issue, the threats that they are going to face from the climate change. So multilateralism at the moment is going to be one of the most important, is going to play a crucial role in maybe mitigating the impacts of climate change and the victory. If you look at the agenda that was there at the G20, it highlights that India at the moment recognize the impacts of climate change. It will have not only on its coastal region, but also across the region. And once you have instability in the within the region, then the impacts on that particular on India is going to be very high. So what is underwater domain awareness framework, how do we integrate it in multilateral, and how is it going to address the climate change issue? So the underwater domain awareness framework, which is proposed by the Maritime Research Center, MRC, exactly aims to address the need for policy and technology intervention which will improve the understanding and management of the underwater environments. So climate change, which pose a lot of threats to the coastal regions, so enhancing UDA capabilities can help the coastal states build resilience against these impacts. So now, for example, monitoring the vulnerable species and ecosystem, UDA enable tracking of migratory pattern, identifying the endangered species, and assessing the health of the coral reef. If you are able to monitor what are the vulnerable species and the vulnerable ecosystem, your approach is going to be more comprehensive and targeted towards addressing the cause. Then disaster preparedness and early warning system is something which is extremely important if you want your country to be prepared for disasters in advance. So UDA contributes in minimizing the devastating impacts of the climate disasters. It does not say that we will stop the natural disaster, but we will be better prepared in order to tackle those natural disasters in a timely and more targeted, and there will be more timely and targeted response available to us. Then resource management. In resource management, UDA supports the sustainable resources exploration and regulation, which helps in maintaining the healthy marine lives. Once you have the healthy marine lives, the fishing will also increase, the dependencies of the coastal states on the fishing is very high. So if you are able to preserve the fish population in your region, we are very much likely to make sure that your own country or your own coastal states are going to be going to be more sustained in terms of fishing and their livelihood. Then what are the technology advances? The artificial intelligence and the learning algorithms, which helps us analyze the vast amount of data, which provides an actionable insight into marine ecosystem dynamics. So AI and ML can enable the expert to identify and monitor the vulnerable species, track the migratory patterns, assess the health of coral reefs, and enhance the early warning system of the natural disaster. Now, the second last is capacity building and adaptive strategies. Investment in UDA capabilities is definitely necessary for the coastal states to remain competitive and adaptive in face of climate change. So the UDA framework encompasses various aspects, which includes offering precise input on resource availability for effective exploitation, then enhancing the understanding of habitat destruction and species vulnerability, which can be caused by the human activities, then focusing on acoustic capabilities and capacity building as our core requirement for effective UDA implementation. Last is international partnership. We cannot do this alone. The impacts of climate change is going to impact everyone. So not one single country can mitigate it. Not one country can actually contribute in mitigating the impact. So we need to work together. We need to have a more collaborative efforts among the nation, and such as constructs like IORA, BIMSTEC, then Maritime Conclave. They can actually strengthen the maritime security. They will promote the sustainable resources management and will also enable for more effective responses to the natural disasters and other shared challenges. So in conclusion, UDA definitely offers a promising solution to the very complex problem which is posed by the climate change, which is associated to the coastal communities as well as to the marine ecosystem. It represents a strategic opportunity for the international cooperation that will benefit not just the individual country, but it will also enhance the global efforts towards sustainability and resilience. To sum it up, we also the realization of the true potential of the ocean can only be accompanied by the awareness to drive the economic development from marine resources, while ensuring that there is a conservation sustainable management of the marine ecosystem. And for that, you need to understand the underwater ecosystem. If you don't have understanding of the underwater ecosystem, your responses are not going to be very targeted and comprehensive. Therefore, we need to adopt a UDA at a multilateral constructs. We need to advocate as individual country or as a global country that there should be a underwater domain awareness discussion at various constructs, be it IORA, be it BIMSTEC. Otherwise, we won't be able to solve the solution problems on our own. With that, thank you for your attention. I would be very happy to take any question in the later on in the discussion. Over to you, Nishtha.
Thank you. Thanks, Vidya. Can we have Anjali back with her presentation?
Yes, ma'am.
Ayush, you can make her presentation.
Sorry for the connectivity issue. Yeah. So, good evening again, everyone. I'm Anjali Kumari. I'm third year undergraduate student in the Department of Chemistry at IIT Kharagpur. Currently, I've been working as a research intern at Maritime Research Center, Pune, and my research topic is water quality management system. Next, I would like to present a short presentation to explain my project. So let's have a quick look on the table of contents that I'm going to cover throughout the presentation. The overview, the water quality parameters, what are the sources of water pollution, what are the water quality standards that set by different authorities like WHO and BIS, uh, the guidelines that I have come up after the research, and what are the future scopes of these guidelines and the conclusion. Now, now, next, let's understand what water quality management system is. So, when we say water quality management system, we are concerned about the water quality, the qualitative analysis, and not the quantitative analysis. So, a water quality management system involves various steps, starting with source water monitoring, assessment and analysis, treatment process, distribution system management, regulatory compliance, stakeholders engagement and their education, and the continuous improvement. Now, let's understand why it is important. So, one step back. So, sorry. Uh, according to a UN report, approximately 3.5 million fatalities occur annually due to the poor water quality distribution. And the next is environmental protection. A lot of biodiversity destructions are happening due to the poor water quality. And the third one is the most important. The sustainable development, which help in the agricultural and economic growth. Now, moving on to the next slide. Uh, uh, we have some water quality parameters that I've been analyzing. The first one is physical parameters, including temperature, salinity, turbidity, and color. Then chemical parameters, including pH, nutrient contents, total dissolved solids, dissolved oxygen, hardness, and heavy metal contents. And then the biological parameters, including bacteria, pathogens, and algal blooms. I have discussed all these parameters and how they affect the quality of water in detail in one of my research notes. So yeah, moving on to the next slide. Uh, let's quickly go through the sources of pollution. So it includes point sources, including industrial discharge and wastewater treatment plants discharge, and the non-point sources, including agricultural and urban runoff. The natural sources also can also cause water pollution, for example, soil erosion and animal waste. So yeah, moving on to the next slide. Yeah. So here I have mentioned the water quality standards set by different authorities, such as Bureau of Bureau of Indian Standards and WHO. So these are the guidelines set by these authorities for drinking water quality, and it is important to have a compliance with the above standards of water quality to ensure public and environmental health. Moving on to the next slide. So after having a good amount of literature review, I have come up guidelines for water quality monitoring system in the following 8 steps. So step 1 being the setting of water quality monitoring objectives, then assessment of resource availability, then reconnaissance survey, and then network design, then sampling, laboratory work, and the data management, and then the quality assurance. And then let's now discuss the components of these guidelines. So after we have set the water quality monitoring objectives, we need to assess the resource availability. For example, the laboratory facilities and their competence, a good transportation system, and the manpower. Then step 3 comes where we need to have a good mapping of the area where we are going to analyze the water quality, and the background information, including what are the human activities going through that particular water body, and the potential polluting sources, the water extraction and their uses, hydrological information, and water regulation. Then the network design, which includes the selection of sampling locations, the parameters to be measured, the frequency of sampling, and the components of the samples, including water, sediment, or biota. Then step 5 is sampling, which requires representative sampling, field testing, sample preservation, and transport of the sample to the laboratory after all these steps. And then the laboratory work comes, which include physical and chemical analysis, including microbiological and biological analysis of the sample. After that, data management is one of the most important steps in the water quality monitoring system, which requires a good storage, statistical analysis, presentation, interpretation, and the reporting of the data uh, after the analysis. Then the last step is quality assurance, which include the production of reliable data and the quality control, including internal and external both. So after that, I also came up with some of the guidelines on water quality management, on the management aspect, which include availability of adequate resources for water quality monitoring, awareness about the objective procedures and the time schedule among everyone who is involved in the process, and then the people who are involved should be motivated and work with their full interest, and there must be the accountability for everyone should be fixed, and then uh, ensure that there is a enough communication among all the groups, and proper transfer of data, uh, availability of adequate funds, and a proper availability of transportation, and the annual maintenance contract to repair laboratory equipments, and the and their and the regular analytical quality control exercises. Moving on to the next part, we have future scope of these solutions. That is to incorporate the advanced technologies for water quality management system with underwater domain awareness framework, which has 4 components. The blue economy, strategy, security, digital transformation, and the sustainable development. Uh, I would like to conclude my presentation with the quote that says preservation is better than cure, and means nothing can be better than prevention, no matter how advanced the technology becomes. So thank you so much for your kind attention. Thank you.
Thank you. Thanks a lot, Anjali. Now we'll move on to the second segment of today's workshop. The second segment includes presentations on the topic sediment management. First of all, I'd like to call upon Romit Kavre, fellow at MRC, to make his presentation on the topic holistic view of sediment management in the Indo-Pacific. Over to you, Romit.
Good evening, everyone. I am Romit Kavre. I'm currently working as a research fellow at MRC. I am discuss about the sediment management in the Indo-Pacific. Now, this is something that I have been working since the past 2 years now. So I'll start with understanding how what are basically how the sediments are very much crucial in the water systems. Uh, the sediment fluxes, what are the various sediment levels, the siltation level is very much crucial to understand how are the effects of the various human influences or the various natural processes that have shaped the sediment flux. Uh, for this, now this sediment flux has very much importance in various domains. So we have the water quality, the sediment classification, the topography, the bathymetry. We'll talk about it later in the discussion. But this has wide-ranging applications in a lot of domains. Now, typically, the sediment management plans, whenever they are being developed, they are mostly developed considering what are the various local conditions. Now, when we talk about the Indian subcontinent or the tropical region of the Indo-Pacific, we do not have basically understanding of the various of the local dynamics, what are the local conditions that shape the various sediment dynamics that are there. Now, due to this, there is a lack of data collection and then holistic planning purposes. In fact, when we talk about the role of the sediment, it has very much economic, environmental, and social role as well. That's what are the various sediment monitoring techniques, understanding the various sediment dynamics becomes imperative. For this, what we are trying to see is within the sediment management, how can we have an holistic view which would integrate the various the water quality, the sediment flow, the sediment dynamics, and once the sediment has been properly deposited, how does it shape the various applications that are there. So we talk about sediment management, we're mostly concerned with the two systems that are there, the freshwater systems and the coastal regions. Each of their own nuances, we need to properly understand them. When we talk about the freshwater systems, there are the major river systems are there. We have the dams and reservoirs. So when we talk about the river systems, we have the Ganga, the Brahmaputra rivers. These experience excessive sedimentation, especially during the monsoonal season that we have the intense monsoonal system. Apart from that, we have excessive soil erosion. This soil erosion and various agricultural practices, this leads to a lot of sedimentation, the sediment inflow into these river systems, and this affects the efficient working of the inland water systems that are there, various the freshwater marine ecosystem is there. This also, the excessive sedimentation also affects the storage capacity of the various major reservoirs that are there. So the Central Water Commission of India, it has estimated there is an annual reduction of around 1.5% of storage in the major reservoirs, especially due to the siltation that is there. So freshwater systems, it has a wide-ranging applications concerning the total watershed that is there. Now, when we talk about the coastal regions, they boast a different type of ecosystem. So it boasts various estuaries, deltas, the coral reefs are there, mangrove systems are there. So it has the river and the sea interface. Basically, it is there. Apart from that, the coastal regions also boast the port systems that are there, which are very much crucial for facilitating the global trade. Apart from that, the exclusive economic zone is there, which is crucial for the oil and gas exploration or various navigation purposes as well. And with the rise in the human interventions in the exclusive economic zone, we need to understand their case studies. What are the requirements in the coastal regions? What are the challenges that are faced in the coastal regions? Now, all of this sediment management, we are mostly concerned in the two major aspects, that are the sediment classification and the sediment transport. Now, sediment classification is basically understanding what are the various sediment types, understanding the various properties of the sediments, what is the seabed layer, what is the depth and thickness of the sediment bed layer. This has applications in various uh, defense purposes. When we talk about offshore construction, navigation, we have the benthic ecosystem monitoring. All of these are characterized by the what is the bathymetry or what is the seabed characterization at the button that we are included. In fact, the seabed is characterized by the various natural processes that have occurred over millions of years, and what are the current what is the current condition needs to be properly assessed. For example, if we have to build a refinery or some offshore construction needs to be done, found understanding the seabed characteristics is very much crucial for the foundation design of such crucial infrastructure. Apart from that, we have the polymetallic nodule program. The sediment classification techniques can be useful in this in assessing the polymetallic nodule viability, and also understanding the and monitoring what are the various we have the marine trash, the marine litter, or these various microplastics that have been buried within the sediments. Sediment classification techniques can help us in identification of the various what are the various components that are present in the seabed, in the biotic as well as in the abiotic part of the ecosystem. The other part is the sediment transport. Now, this sediment transport basically means what are the various natural or the human processes that shape the sediment flux, its transportation, its deposition. What are the various there are natural phenomena, coast. It is also interlinked to the various coast erosion processes, agricultural processes that are there, the monsoonal system. Sediment transport has implications on the various applications, because if we do not understand what are the localized sediment dynamics, we can't have proper monitoring efforts. In fact, when we talk about our port systems or the inland waterways, we have to conduct regular dredging. But what is the use of such regular dredging if we don't understand what are the local sediment dynamics that are there? Because once we have a particular project without understanding the local sediment dynamics, uh, it just goes into waste, as again, due to the natural phenomenon, the sediment might again get transported into the very same place. The sediment might get accumulated, and it may hamper the effective movement of navigation of the various ships that are there, which may require again regular dredging would be required. So we need to understand what data needs to be collected regarding what are the localized sediment transport in a particular region. Now, all of this sediment management, the sediment classification, and the sediment transport, why are we very much focused on the tropical conditions or the Indian subcontinent? So the Indo-Pacific is the Indian Ocean is the warmest among the major oceans. Now, this higher equatorial temperatures leads to an intense monsoonal system. This again has this affects the urban floods that are there, or excessive sedimentation are there within our major water systems or major reservoirs that are there. Apart from that, the Indian Ocean, it boasts around 30% of the global reef cover. It has 40,000 square kilometer of the mangrove that are there. It has 9 major marine ecosystems. So it also has a rich biodiversity. And we do not have a proper understanding or proper knowledge of the distribution of such biodiversity. What are the effects of the various human activities that are there, or the effects of the climate change? Thus, we need to have proper data collection systems in place. Now, when we talk about the underwater monitoring as well, when we talk about acoustics, the Indian Ocean behaves very uniquely. So the so far channel depth, which is linked to the proper underwater communication, the so far depth is very much higher in the Indian Ocean region, thus rendering it acoustically shallow. Now this leads to a lot of multi-part propagations. When we talk about the working of the acoustic systems, there is a lot of acoustic and noise that the tropical use within the data. So when we talk about the data collection systems, there are various new sensors or the remotely operated vehicles, autonomous underwater vehicles have been developed in order to collect the data that has been there. But again, proper research and development needs to be undertaken in order to find out what are the proper appropriate sensors that are required. So there can be the multi-beam echo sounder, the side scan sonar, each having their own application, each have their own frequency and resolution trade-offs. Understanding what are the various what are the appropriate sensors that are required for our application. Thus, there are a lot of development challenges in developing an in-house monitoring system. So the Indian ocean or the tropical conditions, it leads to a lot of variable in the raw data. There are a lot of noise in the medium surface and bottom fluctuations are there. So whenever the acoustic systems are brought into or are deployed in this system, there are challenges in deploying them, in calibrating and maintaining this equipment. In fact, there are a lot of constraints in the equipment and operational cost of such equipment. Now, this leads to an decrease in the operational efficiency to around 60 to 70%. Now, reduced efficiency, we have to mostly depend on the Western nations that are there, with India not able to develop its own indigenous systems. Thus, with the advancement of technology, we have the Internet of Things, the AI, the 5G technology. We can have real-time data transfer. We can have real-time data analysis. How can we integrate them with the current conventional techniques? So, when we talk about the sediment transport mechanics, how can we integrate the real-time feed to find out the current what are the various current processes that shape the sediment deposition that are there. We can also have a shared data system so that we can share real-time data with the various stakeholders that are there, which would be very much crucial for the process for the real-time data processing. We have the data analysis and then proper decision making between the various stakeholders that are there. That's what we are trying to develop, is the 2C, to understand and the to share concept. So in the 2C, we are trying to see for each of the application that we have is of interest, what kind of hardware, what kind of sensors are required for that. And once the various sensors are found out, what are their specification, how are they going to be deployed, what kind of data processing needs to be done to the collected data. The tropical conditions have a lot of noise and multi-part propagation. What are the filtering techniques? How are we going to interpret the data? Because again, different stakeholders have their different requirements. So based on their need, how are we going to understand the various data processing techniques? And then finally, how this data is going to be shared between the various stakeholders. That comes under the to share part. In this, how the UDA will help. So basically, at its core, the UDA talks about the competence of the acoustic systems, developing the sensitizing the various stakeholders, taking in what are the specific needs, and then leading to a digital transformation. In this, we would like to have a digital. We would like to have the outreach for the various stakeholders that are there. Seminars, workshops would be held to sensitize the various stakeholders that are there, initiating projects for the various policy and technological interventions that are required for the sustainable development. In that, the user, academia, and industry partnership would be very much required to develop or to undertake research and development activities leading to to long-term sustainable projects that are there. We talk about integration of the sustainability, integration of the climate change. All of this would be required when we talk about the various stakeholders that are there. Basically, in this, we'll also need to integrate the marine spatial planning. So, marine spatial planning would again, we have various active stakeholder consultation would be required, and then how is the with the data, how is the proper decision making undertaken? We would require the marine spatial planning can help us in that. Basically, what we require is understanding what kind of data is required for a proper policy intern at the local, regional, and the national level, which would integrate the various stakeholders that are there. And basically, an integrated approach is required when we talk about the water quality management, water resource management, the sediment classification applications, the dredging, working of the ports and the various inland waterways as well. So how are we going to safeguard that and proper environmental impact assessment? Basically, having a holistic environmental impact assessment of the various sediment related applications that needs to be seen. So with this, I'll conclude the presentation here. Thank you.
Thank you. Thanks, Roman. Next, can we have Bhavin Jain from IIT Bombay to make his presentation?
Good evening, everyone. I am Bhavin Jain, currently pursuing a BTech degree in civil engineering from IIT Bombay and currently a research intern at Maritime Research Center. So my project was basically to perform sediment classification using machine learning algorithms. So first I'll explain everyone a bit about my project. So this was mainly a data analytics or data science project, and it is based on the Kharagpur lake data. So Kharagpur lake data was collected around 2019 for the purpose of sediment classification by one of the fellows at Maritime Research Center.
Bhavin, you'll have to make your presentation full screen. It's not.
Sir, it is full screen only. On my laptop, it's full screen. Is it not visible there?
Bhavin, it's.
I will try once.
Yeah. So what you can do
Now?
is you can put it in the presentation mode. That small icon that you can see.
I put it in. I clicked on presentation mode only. Now?
Bhavin, you have to share your entire screen.
Acha, okay.
Yeah.
I will do.
So at the bottom, if you can see some of the icons, there's notes written and there are like 3-4 other icons present over there.
Just a second. Now?
Yes, it's full screen now.
Okay. So yeah, I was explaining about my project. So it is basically based on Kharagpur lake data. It was collected using a edge text sub-bottom profiler. So that works on the basic principle of sending sonar waves, and then it performs imagery as well. So it performed on a depth from 10 meters to 15 meters range. And so because from the surface till 10 meters it was about water, and then below the surface it took about 5 meters of imagery. So I raw data at different frequencies, different sonar frequencies. So now the problem at that time to solve a sediment classification, and the problem still remains the same as well. But the previous work which was done, it was done is using mathematical models, and my aim was to using machine learning algorithms. So what is the importance of my project is basically that currently sediment classification is very important. A sediment classification is needed to get past historical information about the geological area. It is also needed to. It can also be used to analyze climate change, and it holds a lot of importance in classification. And currently, the methods have evolved obviously from going to do basic sieving and plotting grain size to going methods such as diffraction, advanced image analysis, remote sensing. We have evolved to modern methods, but all of them have an issue which is a very heavy pre-processing and post-processing to get the final result, which which can eliminated by this machine learning thing, which is you can use support vector machines, CNNs, which are on the right side. So this is basically the lining of my project and why it's really important. Because sediment classification is very important for UDA, and it's going to get more important in the upcoming thing, because industries, human activities, industrial activities, all of them affect sediment layers at a very level. So industrial activities lead to a larger runoffs, and then they can change the type of sediment. Over the years, we can see a very significant change in the type of sediment layers and their composition, which can be used to analyze how we are actually impacting the environment and the river and water bodies around us. So now, what was my methodology for the project is, so I was given for raw data from which was from sub-bottom profile as explained before. So first part was to analyze the data of what I exactly have. So after analyzing, so I figured out that I would be using data for majorly two purposes. One is to label the raw data, to label the each GSF files at different frequencies which have been given to obtain wide training, and another use of the data would be to obtain the features from it of which a combination of features then can be used to train different types of models. Now, to label the raw data, two methods could be used: reflection coefficient method and relaxation time method, which were used previously by the research fellow which was working on the project. So, what is reflection coefficient? Reflection coefficient is basically the ratio of the transmitted energy upon incident energy, while relaxation time is, so basically the data which I've been given is, it is signal amplitude data. So now frequencies can be calculated from these signal amplitudes. So the change in frequency from one layer to another and the change in depth, the ratio of that is basically relaxation time. So for different relaxation times or for different reflection coefficients, we can map the sediment types. So that is how I have planned to do the label of raw data, and that's what I'm doing currently. Then I will be extracting different features from it, almost 10 to 15 features, and I will train different types of models, which I'll be explaining further in my presentation. And after this, I'll just select the best model by calculating the accuracy which test dataset. And so this I'll be splitting my raw dataset into three parts. One is training data, which will be majority of it. Then and the other part I'll be splitting into two: testing and validation datasets. So now for feature selection, I extracted various features such as mean amplitude, the variance of the amplitude, skewness of the amplitude, max win, which can be seen here in the images. So all of these features are quite important. I also performed on how much important they are. I was researching on the PC, which is principal component analysis. It is an important thing in machine learning algorithms, which can tell us that how a factor is related to my core problem. So I was doing some experimentation with that to select the correct features, because this part is the one which is most important, because we have to select such features that, let's say, in the future, if I incorporate other types of data, not only the data from sub-bottom profiler, so the features should be such that they can also accommodate the values obtained from the data, and we can still get a reasonable accurate output. Now, moving on to the types of models which can be implemented are: one is logistic regression, which is on the bottom side. On the top right, you can see a support vector machine, and on the left side, we have a neural network. So all of these models are currently I'm working on the logistic regression one. So basically, a logistic regression model is a linear model where, let's say, if I have currently extracted 5 to 10 features, and I have to calculate a coefficient of bias for each feature. So currently I'm working on the logistic regression model. I also plan to do a similar implementation support vector machine and CNNs after getting the features which are important, which I will be checking through logistic regression. So these are the models which can work, and I'll be selecting the one which will give me the most accurate result. Now, this project obviously holds a lot of applications. First of all, it eliminates the tedious task of pre-processing the data, obviously perform the task of sediment classification. And as I explained before, sediment classification is needed for a variety of important purposes. The future scope of the project can be that we can incorporate other sources of data in it, such that we can help eliminate on-ground observations, such as remote sensing works purely on satellite and receivers. So in that time, we don't need to go on site and install a sub-bottom profiler or SSH, which is sonar scan, and get the data. If we can automate this whole process, it can be really easy analyzing this data. Another aspect is to make models more accurate. So it can be used for more advanced features as they require very accurate results. Because uh, the data, it would require obviously a lot of training, and maybe in the future we can reach a point where we have a very high accuracy, maybe above 95 or 98%, such that it can be used for high-end analysis. I hope I could convey everyone the importance of sediment classification and how machine learning is being incorporated in it. Already, a lot of projects have happened by someone by the Shanghai Institute, one in Mexico. I've analyzed many case studies, and I'm trying to extract something important from them and give my own input. So I would like to thank you all for listening to my presentation. Thank you.
Thanks, Bhavin. Thanks for your presentation. Can we now have Pradnaya Kumbhare from IIT Bombay to make her presentation. The topic of her presentation is sediment management transport steps. Pradnya, over to you.
Yes. So hello everyone present here. I'm Pradnya Kumbhare, currently a third year undergraduate from IIT Bombay in electrical engineering department, and I am a research intern at Maritime Research Center, and today I'll be presenting on sediment transport study. Let's first talk about why sediment transport study is important. So the monsoon season in India, it causes excessive siltation because of high speed of water, and our reservoirs are losing their storage capacity because of sedimentation. And sediment transport study is thus very important to understand the damage that is being caused to national economy. Erosion and aggradation, these are two most important geological and natural processes that are responsible for bringing down large amount of sediment. And to solve this, policymakers are addressing sediment transport deposition and erosion. Sustainable practices can balance sediment flow while maintaining river health, as understanding this unique sediment dynamics of Indian rivers is extremely important. So the unique characteristics of Indian tropical rivers. So Indian tropical rivers, they exhibit several unique characteristics that makes them unique from other rivers in other region. Himalayan rivers flow remain consistent throughout the year, whereas the Western Ghats serve as the main water divide for peninsular India. Now, because of the unique geological context, as the Himalayas are relatively new mountain ranges, it continues to grow at the rate of about 10 millimeter per year. And the Himalayan rivers carry a mixture of loose mud, silt, pebbles, soft rocks due to the ongoing tectonic processes and sedimentary rock composition. So, in my project, I studied 3 case studies, and the first one is the Brahmaputra River. Brahmaputra River spans four northeastern states of India, that are Arunachal Pradesh, Assam, Meghalaya, and Nagaland. It drains an extensive area. A lots of soil is lost annually due to erosion, carrying away dissolved crop nutrients and into various things as well. According to the Brahmaputra board under Indian Ministry of Water Resources, the river's course has frequently changed due to high silt deposition, and the excessive silt has led to braiding and meandering pattern in reverse alignment. I studied the HECRA's 4.1 model. It is a one-dimensional computer-based simulation model which is employed to analyze the quasi-unsteady flow, whose simulation is used for development of the model of Brahmaputra River. Now, in the context of Brahmaputra River, which is responsible for frequent floods and losses of lives, accurate forecasting becomes crucial for human safety. However, the existing data and the information available for forecasting are inadequate, and it poses a significant challenge in today's time. Now, talking about the methodology of this model, the calibration process involves the observed flow data to determine the appropriate roughness coefficient, and by comparing different roughness coefficient with the observed values at these different river sites, we can find Manning coefficient, which can further be used for channelization of Brahmaputra River. Let's move to the second case study, that is JNPT Port. So the Jawaharlal Nehru Port Trust, which is situated in Navi Mumbai, is the second youngest and most important modern major port in the country. The channel length was extended from 29.5 kilometers to 33.5 kilometers, and JNP has further proposed deepening and widening the existing channel to meet the depth requirement of these new generation ships. These results indicate that the sediment resuspended due to dredging operations is unlikely to disperse into tidal flats. My third case study is the Cochin Port. So Cochin Port is located in the state of Kerala in the southwest India. It lies major to major international sea routes, and it has explored strategies to enhance the dredging efficiency, including allowing ships to partially navigate through fluid mud. A comprehensive approach involves a detailed understanding of siltation processes and establishing a safe threshold for water depth, draft, and underwater clearance to ensure this ship navigation through fluid mode. Over 20 million cubic meters of siltation occur annually, which necessitates the need of maintenance dredging, and it is a significant cost for the Cochin. So here are a few recommendations of dredging in Cochin Port. The container vessel would require the additional dredging in offshore part of outer channel, while the additional dredging during a monsoon is required in the nearshore part of the outer and inner channel, while less dredging effort is required in LNG terminal and minor reduction is suggested in ICT terminal. Lastly, let's look forward to the numerical models for sediment transport and harbor. It can be created in the areas with severe siltation challenges once we grasp the local conditions and gather accurate data. Now, identifying the sources and causes of siltation can easily be determined by this model. Yeah, that's it from my side. Thank you everyone for your time. Have a great day.
Thank you. Thanks, Pradnya. Now we'll have the last presentation for the day, and we have S. Arulanandan from IIT Kharagpur, who's going to make the presentation. Over to you, Arulanandan.
Hello everyone, my name is Arulanandan. I'm a third year undergraduate student of the Department of Electrical Engineering at IIT Kharagpur. I'm currently a research intern at MRC. My project topic is sediment management focused on dredging. First, let's understand the importance of dredging. In tropical regions, there is a common issue of excessive sedimentation, which reduces the channel depths of water channels, which are important for the economy and navigation. And dredging helps in these situations by removing the excess sediments from these water channels and thereby ensuring proper navigation. And considering the tropical region, there are different climatic conditions and rich biodiversity, which makes the dredging more challenging, and the complete process of dredging needs more proper planning. My field of research lies in understanding the entire process and giving a guide to conducting dredging in Indian waters. This is the basic flowchart of the steps in the process of dredging. And the first part of dredging is the planning and designing phase. In the first part of planning phase, we have the decision of determining the type of dredging project. In India, there are two major dredging projects, which is classified into capital dredging and maintenance dredging. The capital dredging involves conducting dredging in a completely new area, which requires complex planning and machineries. And maintenance dredging is removal of sediments from existing channels in ports and harbors for smooth navigation. This is the general workflow of planning phase in our Indian guidelines. When I went through this guidelines and planning phase, I found a small issue with how things are being planned in India. That is the weightage given to stakeholder management. This aspect is very important, as the entire project of dredging is determined by the relationship between the stakeholders, and this issue can be resolved by application of UDA framework in the process of dredging. The application of UDA framework in the process of dredging will make the communication among the stakeholders more efficient and helps in policy and capability building. It gives a structured approach towards facing many problems that occur during the planning phase of a dredging project. The equipment selection is an important step in the execution of dredging projects. Generally in India, the cutter section dredgers are used to dredge hard-packed materials, especially during the capital dredging. And suction hopper dredgers are used for soft sediments, mainly during maintenance dredging. The monitoring dredging is an important aspect during a project execution phase, and the implementation of the marine social planning will be helpful in understanding and processing the data gathered from the bathymetric and acoustic sensor, bathymetric surveys and acoustic sensors. Finally, let's understand the final phase of dredging, which is sediment disposal. This sediment disposal is a process of safely managing and removing sediments that are obtained from the dredging activities. This is the data that I have gathered from the ports records from 2021. And as you can see, the main method of sediment disposal carried out in India is open sea disposal. This isn't like a perfect method of sediment disposal, as directly introducing the entire sediment into the local aquatic system will increase the turbidity and will affect the lives of local aquatic systems. Let's take a case study that I have done on a Piagora channel in Brazil. And when they were doing dredging project on the Piagora channel, they discovered that introducing the sediment dredged into the direct oceanic disposal will cause a major degradation in the local aquatic system. So they have adopted a strategy of confined aquatic disposal, which is a safer method and safer alternative. And these methods can be implemented in India with proper planning and calibrations. There are also other methods and strategies that I have included in my first research note, few of which is confined disposal facility, which is similar to the confined aquatic disposal, but confined disposal facility is done on the land. And PFTM is pneumatic flow mixing tube, which transforms the dredged sediment into economically useful materials for constructions and land reclamation projects. And the future scope of dredging, we can apply underwater domain awareness framework and the marine spatial planning into the process of dredging, which will increase the efficiency and planning of the dredging projects. Thank you.
Thanks. Thank you so much, Arul, for your presentation. And thanks to all the participants for sharing their valuable findings and key highlights on the worthy topics that they've done their research on while interning with the Maritime Research Center. Now that we've completed our presentation for day one, we need to focus our attention on our mentors and experts. I am pleased to invite Mr. Ashwin Shroff, who's the chairman of the Board of Directors of Excel Industries, to share his comments and feedback. Mr. Shroff, we are eager to hear your thoughts on the presentations and the work that our interns have done.
Well, thank you very much. First of all, Dr. Das, thank you for inviting me. All these sessions have always been very, very educative, very, very helpful in getting a larger perspective of the issues. And today, for example, the simple looking thing like sediment, the number of dimensions that were presented, really very enlightening, very educative. So, as you have been rightly emphasizing, UDA, underwater domain awareness, is a vast subject, and there are so many dimensions. And the better we understand, the sooner we understand, it will all be helpful to all of us. As you have also been pointing out, that the lot of studies have been done in the western part of the world, which are more in the, let's say, temperate climate, whereas the tropical climate presents different kinds of issues, different kinds of challenges, which has not been studied in depth well enough. So I must compliment you and MRC and all the wonderful colleagues, both in MRC and the interns that you have. And of course, all the supporters like Mudgalji, who have been consistently there. And So it's a wonderful journey which you have been undertaken. So I must again compliment you. The confidence with which most of the interns and the trainees they presented was really wonderful. So not only the study of the subject, but being able to present it in a very, very nice manner in the short period of 10-12 minutes is again something it requires a lot of ability, grasp of the subject, and being able to present it in a manner so that people can understand. So a lot of compliments. The issues that came out and one or two which appealed to me is, of course, climate change we keep on talking about, but some of the figures that were mentioned were really both frightening and eye-opening. That 90% of the CO2 which is generated by us humans is absorbed in the sea, and so we spoil the seas. And when we spoil the seas, and then we talk about the various bad effects and all that. So there's need to do that, and the role of seas in the climate change is very, very important. Also, I always wondered, and today there are a lot of talk about sediments and Brahmaputra and all that. I always felt bad that why Brahmaputra every year, without fail, it has to suffer flooding and so many people affected, so many lakhs of people affected and so many acres and all that. So I can understand and appreciate that, yes, it is not a easy subject, but I think since it has been going on for so long, I hope there will be less politics and more of science going into understanding Brahmaputra and being able to do something about it. So I must once again compliment you and all the wonderful presentations that were made, and look forward to attending more of such things and understanding and learning. And of course, we'll continue to be associated and help in whatever manner. So thank you very much.
Thank you very much, Mr. Shaw, for your encouraging words and insightful feedback. Your support and guidance means a lot to all of us and the interns. Thank you so much for your work, sir. Moving on, we are honored to have Ambassador Anup Kumar Mutkal, whose extensive experience and insights are invaluable. Ambassador Mutkal is a former Indian diplomat who is also a member of FICCI's Blue Economy Task Force. Ambassador Mutkal, can I now invite you to share your comments and feedback with us?
Thank you, Nishtha. Thank you. And Sharaff Saab, it was a pleasure listening to you.
Thank you.
I'm really, really thrilled listening to these presentations. Arnam, it's like, when I see school kids working on puzzles, they will certainly open a box with pieces, and you pick up any piece will make no sense. And then they slowly start fixing those puzzle pieces. And finally, an impressive picture emerges. Now you may like that picture, you may hate that picture, you may be indifferent to picture, but at least you get to know what these hundreds of pieces put together are causing. Now, that is how I look at, for example, the environmental issues. Environment is one word, but it has millions of underlying pieces of that puzzle, right? It behaves in a certain manner, but that behavior is then caused and regulated by hundreds of different factors. And unless, and we may not like that behavior, what happens? We may not like the cyclones, we may not like the floods, we may not like the droughts, we may not like the forest fires, we may not like so many things. But the fact is, these things are happening because of a very complex process. So you cannot simply wish them away unless you understand the process. Now there is a hard way to understand the process, and there is an easy way to understand the process. In fact, the other day I was in a clinic for some reason, and sitting there, when I saw the doctors, because the body, it's like we are talking about global warming. Now, when the humans have fever, it's a symptom. But the underlying causes, it could be an infection, it could be an inflammation, it could be organ malfunction, it could be a malignancy, it could be a genetic disorder, it could be many things. Now, when you go to the doctor, he doesn't have to open the body every time you have fever. Yes. Or you have some symptom. So what do? They run some tests, which are relatively simple compared to opening the body every time. And looking at those test results, conclusion, what could be the underlying reason? Yes. So these are basically standardized, simplified markers of a much deeper and profound problem. But once you are able to come to a conclusion that what could be the underlying reason, it becomes easier for you to treat the underlying reason. Yes. I see the UDA framework in that context. Now, ocean is an immense body of almost 3 times larger than the land. In fact, this planet is a water planet. Because humans live on land, we call it land. We call it mother land. It's really mother water. And in fact, the life originated in water. You know. So it's a huge body, and it in fact regulates not only its own behavior, but it also regulates the behavior of land. So it's a hugely complicated, complex, and important part of the planet. And our understanding of that part is almost negligible. Now we are, for example, we crib about global warming. And what are we looking at when we dig deeper into the causes? We are still looking at causes in silos. We found all right, it could be greenhouse gas emissions, and its concentration variation may be capturing heat, and as a result, there may be warming of the climate. But where is this greenhouse gas coming from? Is it one source? Is it 2 sources? Is it 3, 10, 20, 30, 40? How many we know and how many we do not know? You see, we have to understand carbon dioxide, which is the main greenhouse gas in the culprit for global warming. It has a natural cycle. There are sources of production and there are sources of consumption. And the planet has maintained the concentration for billions of years. Now, which means this complicated planet knows how to manage it. Problem is when we interfere. Yes. In fact, humans have always looked at the environment as an obstacle, unfortunately. Because we wanted to do something and suddenly there was a river on our path. We got angry. We wanted to go somewhere, suddenly there was a mountain in the sometimes there was a fire, we were angry. So we were always angry with the nature because we thought nature was coming in the way. And we started doing things, how to overcome the nature, or in a more crude manner, we wanted to defeat the nature. Can we defeat it? Which means we would not behave according to its requirement, but we will force the environment to behave according to my requirement. Now, as long as it was pre-industrial revolution, an individual could only do that much damage to the environment. You could only produce that much. That's it, because you had two hands. And with two hands, you could only do that much damage. And we started looking for force multipliers. Now, these force multipliers worked at different levels. And for sake of simplicity, the hands, the number of hands increased. Well, just imagine if the world just about 200 million, it became 6 billion. So what happened? The number of hands increased. And then we developed technologies which multiplied the impact of each hand several hundredfold. As a result, our limitation to damage the environment was overcome with technology. We could tame the rivers, burn the forest. We could tame the mountains. We could reduce whatever we wanted. And that is where it started. We were harnessing the resources, but we started exploiting the resources. So much so that our over-exploitation of the resources today is manifold the capacity of the planet. The planet does not have the capacity to regenerate those resources at the speed at which we are consuming. So there is an imbalance. But what's happening? In fact, these imbalances are occurring given the size of the planet. These are occurring at micro level, in silos. Somebody is mining, is not aware of the ocean. Somebody is dumping plastic into the ocean, is not aware of the forest. So these, or somebody is producing, polluting cars. They were not aware of desertification. So these damages were being done in silos. So one silo didn't know what was happening in the other silo, although the silo was environmentally connected to the other silo. So while our understanding was in silos, our impact was global. So we were messing these. Without doing that, these are connected. And suddenly, the environment comes back and says, sorry, my dear fellow, I don't believe in silos. I come back with my general reaction to the mismanagement. Now, back to the ocean, the underwater. I have mentioned it so many times. We see the symptoms over water, but all the causes lie underwater. So unless we understand the underwater domain, we simply cannot sustainably handle the consequences, which are symptoms, including global warming. Now I heard somebody saying, global warming causes acidification. No, it's the acidification which causes global warming. Yes. And what is that acidification? Is it a simple process? The answer is no. It's an extremely complex process why the oceans are getting acidified. Now, either, as I said, either we can open the body for every symptom, or we can develop some kind of standardized markers for understanding the underlying complex reasons for simple methods. That is where I think the underwater domain awareness, the UDA framework, comes into, which means we want to generate all possible data underwater, then analyze that data with respect to the functions that are carried out. The physical functions, the chemical functions, the industrial functions, the social functions, the biological functions. And then develop those markers that if this happens, this must be the cause. Now, I always give this example of El Nino or La Nina. Now, both are extremely complicated processes. But what is the marker? The marker is when the variation in temperature exceeds 0.5 degrees, we know that whether La Nina is taking place or El Nino is taking place. Can you see this simple method of at least getting to know that something complicated is going to happen? Now, that is where UDA can, in fact, create those markers where you take sample symptomology, and based on that symptomology, I'm now going a bit deeper into symptomology. It's not pure symptoms, but you're looking at the physical features, the chemical features, the biological features. Based on those features, you're coming to a marker which will tell you a much more complicated damage is being done. It can advance warn you. It can warn you in time, or it can help you overcome the damage which has already been done. That is where the whole balance of mitigation versus adaptation comes. You see, we are all talking about adaptation. I love adaptation. But adaptation is not the final solution. Because that's a competition between the consequences of the damage and the kind of protection that we are creating. We are not solving the problem, but we are creating some kind of a protection against the consequence. We will raise the protection, say, to a point X. The consequence will become X plus 1. Then we'll raise X plus 1. It will become X plus 2. It will be an endless process of competition between the human capacity to destroy and the environment capacity to come back and hurt the civilization. See, so I think that is where, in fact, I really admire, Arnab, your approach to understanding the underwater. Yes. Because once you understand the oceans, you will not only solve the problems of the ocean, but you will also solve the problems of the land. Because these both are connected. An ocean is 3 times bigger than land. And if I count the depth, the magnitude is much larger. Yes. So I congratulate your participants, but I also want to request them now, can we bring together the pieces of this puzzle or these puzzles and start creating some picture which ordinary people could understand? Yes, the experts can understand the pieces of the puzzle, but the ordinary man does not understand, and the governance is in the hands largely of ordinary people. So we have to convert a technical knowledge into a simple language and simple solutions. With these words, I congratulate you again, Arnab, and I hope these things will move towards creating the larger picture and we do not stay with the pieces of the puzzle. Thank you.
Thank you so much, sir. Thanks a lot, Ambassador Muttal, for your kind comments and your insightful feedback. I think it has always been an honor for the Maritime Research Center to hear you and to have you on our platform in various workshops that we do. Thanks a lot again, sir. Now, moving on, I would like to call upon two special guests that we have for today. Mr. Amar Kaul, who is the Chief Data Officer at Barclays India. After his quick comments, I would request Mr. Vijay Bhosle also, who is a partner at Zeta Capital, to share his quick comments. Can we have Mr. Amar Kaul to make his comments, please?
Vijay sir, I think you can go first. I think he's lost his connectivity.
Students, and I will say you all new India entrepreneurs, and the kind of approach they have delivered is amazing. Thank you, MRC, UDA, making this framework, Commander Arnab Das, Prabhu Taleraji, Mr. Shroff, to be with on this esteemed panel. Today we gather to discuss
Okay, there seem to be some connectivity issues at the server end.
opportunity may be right where you are now. So I believe that there is a wonderful opportunity to marine bio, carbon capture, green shipping and transportation. That key, there is a wonderful opportunity to be that change. Previously, what used to be happening, there is a local problem, and people think that problem is solved, and that is a business for them. I think has been changed in such a way that if it is a global problem, it can be.
I think Mr. Vijay is on mute right now, and there's some sort of internet connectivity issues at his end.
We'll request Prafulji to give his comments.
Hello, everyone. It was, I always feel, and I've always been saying this, that water remains the least understood, most neglected global common. And I'm glad that Commander Das has dedicated his whole life and his mission is to create underwater domain awareness. He, like we all know, 75% remains water, and we have hardly scratched the surface. Water is not like just the surface. Like Ambassador Muttal said, the depth is unfathomable. That is what really needs to be understood. If we have to understand water, we have to understand the depths of water, not just the surface. And the presentation on sediment dynamics and sediment transportation reminded me of, this is used ornamentally, the Narmada stones. They are like all very smooth and rounded, and they're used in so many good locations, as in five-star hotels, in posh buildings, as ornamental stones. And I always used to wonder, why are they, what makes them? It's the flow of the river which makes those stones so rounded and so beautiful. So, there is this saying in English, a rolling stone gathers no moss. I'd like to slightly tweak it, and I would say that a rolling stone gets polished. And that's what is happening here in MRC. We last year had 500 applications from the IITs alone for internship, and we could take only 50. We wish we could take more, but this year we've been flooded with more applications. We've had 800 applications. And that just shows the importance being attached by the best and brightest minds of India to this global common of water, which remains neglected. So I'm very glad that MRC is able to attract so much talent into this domain, and which is the body of work which we have produced over the last few years. All the 8 presentations were very interesting, and I'd like to thank all the IIT students for such interesting presentations. I, for one, was very happy because I see all the silos being broken, being blasted literally, because it was very heartening for me to see the students, IIT technology students, talking about geopolitics, choke points, migration, climate, which I don't think were being taught or addressed in the engineering colleges of India. I'm so happy that these students are addressing these issues, and that's the way forward. That's the way forward as I see it, because we are all interconnected. All these subjects are interdisciplinary and they connect at a different level, and knowledge is universal in that sense. And unless we can integrate this, we won't be able to solve the problem of economy versus ecology. See, ecology and economy need to be in harmony. And that's the only way forward. Otherwise, we are hurtling towards doom and destruction. So I once again thank everyone for those lovely presentations, and the whole team at MRC. You're doing a wonderful job. Thank you, Ambassador Mudgal, and congratulations to you, Commander Das, for taking MRC to such heights and depths. Thank you so much. Thank you.
Thank you, Prafulji. Vijayji, if you can
Yes.
complete your comments.
Yeah. Now I can able to hear.
Yeah, please go ahead. You got muted again, Vijayji.
I never imagined ki this kind of the depth of knowledge everyone is carrying so much, and 100% startups can become from a sea. The next era is maritime, and I can see that there will be a big change into nation's approach in terms of MRC and UDA framework. And there's lots of opportunities are coming in terms of startups, and it will be wonderful to join this community as a startup incubator and to know this all students research papers in details. So there will be a scope of work can be designed and defined.
I think there continues to be some connectivity issues for them.
Ashwin sir, if you would like to give some final remarks after having heard the others. I think we'll close the session today. Thank you so much, everybody. I think I must thank the interns for the wonderful presentation, and we look forward to the next set of presentation. They will cover some other aspects of the UDA framework. And Ambassador Mudgal sir, Ashwin sir, thank you so much. Prafulji, as always, thank you very much for your mentoring and support. And we look forward to seeing you again on the 9th. Thank you very much.
Thank you. Thank you.
Okay, thanks a lot, Anna.
Thank you, sir.
Bye.
Thank you, sir. Thank you, Ambassador. Thank you. Thank you.
Thank you, Arnab sir. Thank you, Arnab sir.
I wanted you to speak. Thank you. Thank you.